Welcome back to another low quality production of Snowball Physics Part 2. Make sure you've watched Part 1 before you watch Part 2. In Part 2 we're going to have a look at a type of scenario where a projectile is launched from level ground as opposed to higher ground as in Part 1. It's launched from level ground at an angle. Let's have a look at a question where a snowball is launched at 13 meters per second and is launched at an angle from the horizontal of 40 degrees. And again, excuse me, and again the way to approach these problems is always to start with your grids. Suvat grid. One for the vertical and one for the horizontal. Let's just mark these out. We've got the vertical and the horizontal. Now, when the snowball is launched in this type of scenario, as it leaves our thrower's hand here, it's moving vertically and horizontally. It's travelling at 13 meters per second at an angle of 40 degrees to the horizontal. So as it leaves the hand, it will have partly an upwards motion, a vertical motion, and partly a vertical motion. So what about our initial vertical velocity and our initial horizontal velocity? Well, we need to do a little bit of work. So if I just move the sheet up there, let's just have a look at that initial launch. We've got 13 meters per second as being our initial velocity. If we break that down and resolve that into two components, that will give us our initial horizontal and vertical components. So in our triangle here, this side gives us our initial horizontal velocity, and this side gives us our initial vertical velocity. And since we have our angle there of 40 degrees, we can use some trigonometry. Now, if you think about Part2a carefully, the horizontal component will be 13 cos 40 and the vertical component will be 13 sin 40. So if we calculate those, this gives us initial horizontal component velocity of 19.96 meters per second and the initial vertical component 8.36 meters per second. I'll just check those are correct, and that looks okay. So back in our grid now, we had to do this here, take our initial velocity and break it down into vertical and horizontal parts so we could fill in our initial velocities here. So we've got our initial vertical velocity is plus, remember it's upwards, so that's plus, this is vertical, so 8.36, and our horizontal velocity to the right, so again this is plus 9.96. Now these values will remain constant. The initial vertical velocity and horizontal velocity was determined by the initial velocity and the initial angle, so these values will stay constant in the grids here for the whole time of the projectile's path. Similarly, the vertical acceleration, we're going to ignore air resistance again, will be minus 9.81, and the horizontal acceleration is 0. And since the horizontal acceleration is 0, we can say that the horizontal velocity will remain constant the whole time. So again, we have plus 9.96 here. So we've set the initial grids up, and as yet we haven't considered any particular moment in time. Let's now think of a question. Now the number of questions you may be asked in such a scenario, you may be asked how long it takes to get to its maximum height, to calculate the time of flight, the time just before it hits the floor. You could be asked to calculate its actual maximum height. You could be asked to calculate the range, the horizontal distance it travels. You could be asked to calculate how fast it's going when it lands and at what angle it lands at. So let's have a look at some of those questions in a bit more detail. So let's start with question 1 here. Question 1. Calculate the time it takes to reach its maximum height. So when you get a question, you have to think carefully about what information you can use from the question to add into the grid. So what do we know about the projectile when it's at its maximum height? Well, just follow my pen nib here and think about the path of a projectile. As it moves upwards, it's going to reach its maximum height and then continue and move downwards. But just at that moment there, at maximum height, it's actually only moving horizontally. If it's reached its maximum height, just imagine if you throw a ball directly upwards. It moves upwards, it slows down, it stops, and then it accelerates back down again. So similarly for a projectile, when it reaches its maximum height, just at that instant there, it's only moving horizontally, it's got no vertical motion. So in question 1, the time it takes to reach its maximum height, when it's at its maximum height, the vertical velocity will be 0. And now we have 3 bits of information in our grid, so we could calculate t, which is what we're being asked to calculate the time it takes to reach its maximum height, and we can also calculate the vertical displacement, which will give us the maximum height. So let's just expand question 1, calculate the time it takes to reach its maximum height, and let's also calculate its maximum height too. So we'll do 2 questions in one there. So we have u, a, v. Let's start first by calculating t. So an equation that involves u, v, a and t. If we go over to our Suvat equations, we can see it's this one here, v equals u plus at. So we've got v equals u plus at only being applied to the vertical. So the final, or the moment it's at its maximum height, we're going to call that its final velocity at that particular time is 0. The initial, remember, the initial vertical velocity was plus 8.36. A is minus 9.81, and we've got t there which we're trying to determine. So if we rearrange that there, we've got 9.81 t equals 8.36. So t is 8.36 divided by 9.81, which is 0.85 seconds. So that gives us in our grid our time 0.85 seconds, and we can also include the same time in the horizontal grid. And now we added the extra question on calculate its maximum height. Well, we've got V, U, V, A and T. We're being asked to calculate S, so we've really got the choice of the two-fact equations. We could use any of them. Let's use this one. V squared equals U squared plus 2AS. We're only applying that to the vertical situation. U is 0 at the moment of maximum height. Sorry, V is 0 at the moment of maximum height. U is 8.36, remember, squared plus 2 times minus 9.81 times S, which we're trying to calculate. So if we do 9.81 times 2, this is 19.62 with the minus. If we move that over here on the left hand side of the equation, got 19.62 S equals 8.36 squared. 8.36 squared is 69.9. So S 69.9 divided by 19.62 is 3.6 meters. And if we return to our grid, we have 3.6 meters is our maximum height.